Hello everyone, this is Shri Krishna Joshi. I welcome you all to the fourth week of this course, Automation in Manufacturing. I'm sure you are enjoying the lectures. This is lecture 1 of week 4, and in this lecture, we will be studying the meaning of measurement system and the potentiometer sensors. The outline of this lecture is as follows. At the start of the lecture, we will study the meaning of measurement system, its elements. Then we will learn the definition of sensors and transducers. We will see what is the difference between the concept of a sensor and a transducer. After that, we will see the classification of sensors or the types of sensors, and we will start learning the constructional details of a typical potentiometer sensor, its principle of operation, and its applications in the industry. Well, the fundamental element of a measurement system is sensor. A lot of sensors are being used in automation. So, we will try to see some of the important sensors which are used in automation applications in manufacturing. Well, let us begin our discussion on the measurement system. So, measurement system, it is the primarily is developed to collect the information on the system status. So, if you recall back that there are various building blocks of an automated system. So, measurement system collects the information from the ground, from the application, and it sends that information to the microprocessor, and microprocessor process that information, and it gives the decision to control the process. So, we need to collect the information from the ground, we need to collect the information from the environment of the processing. So, ultimately we have to collect the information and we need to feed this information to microprocessors. So, collection of the information, feeding the information to microprocessor, these are the basic functions of the measurement system. Based on this information itself, the controlling operation would be done. So, the accuracy of the information and efficient feeding to the microprocessor system, these are the two utmost important requirements of the efficient measurement system. The measurement system has various elements: sensors, transducers and signal processing devices. So, we will see them one by one. What is the meaning of a sensor? The definition of a sensor is a physical element which produces a signal relating to the quantity being measured. So, sensor is a physical element which senses the measurand and it generates a signal, it produces a signal. So, that we call a sensor. So, what may be the physical variables? A temperature can be called a physical variable, or displacement can be called a physical variable, or we may also call the noise or the vibrations. So, these are the input variables or the physical variables and we need to measure them. So, a sensor is a physical element which senses these variables and it generates certain signals. So, that signals may be change in resistance, change in inductance or change in capacitance. But change in resistance or inductance and capacitance may not be useful for microprocessor application. Why? Because the microprocessor understand the language of zeros and one, and these zeros and ones are nothing but the voltages. So, we need to have a signal in terms of change in voltage or a sequence of pulses, and that pulses are nothing but change in voltage. So, when we say that a sensor which produces the change in voltage or change in current, which can be understood by the microprocessor, that system is called as the transducer. So, transducer by definition is a device which converts one form of energy into the other form of energy. Again the physical variable temperature, but it is generating the signal into delta V and delta I. So, delta V is voltage and delta I is the current. So, to have a transducer, we need to attach or we need to add integrate sensors plus the signal processing devices. Then we can get the transducers. So, we can call all the sensors are transducers, but all transducers are not sensors. Well, a simple example is a wire of Constantan alloy, a metal alloy, and it has two elements, copper and nickel. The proportion is 55% of copper and 45% of the nickel. So, this alloy can be called a sensor, as it is generating a signal when there is a change in physical variable. So, let us consider that change in physical variable that to be measured is mechanical displacement. So, mechanical displacement we are providing in terms of tension or compression. So, when this element mechanical element is applied with tension or the compression, then there is a change in electrical resistance of this Constantan alloy. So, as we are pulling a wire or element made up of the Constantan alloy, there is a change in resistance, or we compress it, then there is a change in resistance. But this change in resistance will not be useful to take the appropriate decision by the microprocessor. So, for that purpose we need to add few electrodes, we need to have input output mechanism, and when we add this to the sensor, then we are having a transducer. So, in automation or in applications of the sensors, we are using the additional elements, additional processing devices. These are the signal processing devices. We will be learning the signal processing devices in the later part of our lecture. Nowadays, there is a concept of smart sensors are also coming into the industry. The concept of smart sensor is nothing but it is a plug and play kind of device. So, as we have seen, sensor it is a simple physical element, transducer is having a physical element and a signal processing device. The smart sensors are one step ahead. So, the smart sensors are having physical element, signal processing device and microprocessor as well. So, we can consider a smart sensor as a plug and play device. You just plug it and you can simply sense the variable. So, these devices they are having self calibration capability, they can adjust with changes in the environment, and they are very intelligent, they are having the capability to communicate with variety of other devices which are not in the transducers. Well, such type of sensors are being used as a independent devices in the manufacturing domain nowadays. Now, let us look at various sensors and transducers which are used in manufacturing automation. The first type of sensors are displacement, position and proximity sensors. The automated systems have various mechanisms, and these mechanisms have various linkages, various elements. During the process of operation, these linkages and elements they displace, there is a movement, there is a motion of these elements or linkages. We need to monitor the displacement of these linkages or the elements. Second is the position. So, the automated systems are moving inside a shop floor, and we need to track the position of this system inside the shop floor. So, we need to track the position, we need to locate the devices in the specified the space. So, for that purpose we need position sensors. Proximity. Proximity is the closeness with the object. When the objects are coming closer to the equipment or the instrument, we need to generate certain signals to know the proximity of that elements or proximity of the objects. So, for that purpose we need the proximity sensors. So, displacement, position and the proximity. There are various sensors. These sensors are listed on your screen: potentiometer, strain gauge element, capacitive element, differential transformers, eddy current proximity sensors, inductive proximity switch, optical encoders, pneumatic sensors, proximity switches, Hall effect sensors and many more. So, these sensors are in general used in the manufacturing automation. In addition to the displacement, position and the proximity sensors, we also need to measure the variables such as velocity and motion of either the physical elements of the equipment or the objects for which we are carrying out the automated processing operations. So, for velocity and motion, incremental encoders, tachogenerators and pyroelectric sensors are used. We also need to measure the force. So, for that purpose, strain gauge based load cells and piezoelectric based sensors are used. In automation, there are a lot of fluids being used. It may be gas or it may be a liquid. In gas, air or it may be some other gases are to be used for the applications, or in fluid it may be water or some chemicals or it may be a syrup. So, for that purpose various sensors are used: diaphragm pressure gauge, capsules, bellows and pressure tubes, piezoelectric sensors and tactile sensors. Then the flow of the liquid. So, to measure the flow of liquid, orifice plate and turbine meter are used. To sense the level of the liquid, floats and differential pressure gauges are used. Temperature is a very important parameter as far as the process monitoring and control is concerned. Temperature suggests or temperature indicates the health of the equipment as well. So, for that purpose, bimetallic strips, RTDs, that is resistant temperature detectors, thermistors, thermodiodes and transistors and thermocouples are used. Lights are used to carry out the office automation or the home automation. So, for that purpose various diodes, resistors and transistors are used. Now, let us come to our first group of sensor, that is displacement, position and proximity sensor. As I mentioned, we need to measure of an amount by which an object has been moved. So, this object may be the mechanism or the element of a particular mechanism of a machine or an equipment, or it may be the object. So, we need to measure the displacement, we need to track the displacement, we need to record the displacement. Then the position sensor. So, in these sensors are used to determine the position of an object in relation to some reference point. So, this reference point may be a reference point of the equipment or it may be the reference point of the space in which the objects are moving. Third is proximity sensor. The proximity sensors are the type of position sensors only, and they are detecting the movement of the object with some particular critical distance of the sensor. If the object is coming closer to the sensor and if it is crossing the critical distance, then the sensor detects that object. So, these sensors are available in the industry in contact or non-contact mode. Now, let us come to the first sensor, that is the potentiometer sensor. So, potentiometer sensor has a resistance element and a sliding contact. These are available in linear or rotary format. So, as the length of the sliding contact changes, the resistance of the system changes, and that resistance is producing further voltage output. So, the length of the sliding contact is affecting the resistance of the system, and it is affecting the potential difference across the connections. So, if we connect the sliding contact with the physical element of which we need to measure the displacement, we can easily compute the displacement by calibrating the change in potential difference inside the circuit. A typical linear potentiometer has a long wire and there is a slider. So, such a long wire based linear potentiometer, it is difficult to handle, it is tedious, and we cannot use this as a sensor. So, for that purpose the rotary modes or rotary type of potentiometers are used as sensors. So, these rotary sensors has wire wound track or a film of conductive plastic. So, this wire wound track has number of turns over the core of the sensor, and as the wiper or as the slider is getting contacted with the turns, we are measuring the resistance according to the contact of that slider with a typical number of or a specified number of turn on the circular wound track. So, the resistance we can get when the wiper is connecting to or it is contacting to a wire. So, nowadays a film of conductive plastic is also used. So, this film is nothing but a plastic resin which is embedded with carbon powder. So, instead of having number of turned coils, the carbon powder is embedded with plastic resin and the wiper is moving over the plastic resin. The carbon powder is conducting. So, wherever the wiper is connecting, we are getting the resistance accordingly. A typical application of potentiometer sensor is shown on the screen. Here we need to measure the linear displacement by using a rotary type potentiometer sensor. So, for that purpose we are getting a string or a cable, we are winding this string or the cable over a threaded drum. This drum is mounted on a shaft, and on the shaft we are having a coil spring. At the end of the shaft we are having the potentiometer sensor. So, the potentiometer sensor has a resistive strip and a wiper arrangement. There are 3 terminals, 2 terminals of the resistive strip are attached to 2 ends of the wire. So, this is the pulling element or the contact element of this sensor. So, this element is in contact with the application of which we need to measure the displacement. So, consider there is a pull in this contact element. As there is a pulling moment, the drum is rotating in clockwise direction. and as the drum rotates in clockwise direction, the wiper also rotates in clockwise direction. So, as the wiper is rotating along the clockwise direction, there is a change in length of contact with the resistive strip. So, the distance, the linear distance is the function of the change in contact length of the potentiometer sensor, and further it is a function of the resistance. So, this delta R will further be used to generate the appropriate signals, that is a delta V or delta I current signals by using a Wheatstone bridge device. Because as you know, delta R signals cannot be used by the microprocessor to process the information. So, we need to convert these signals from one form of energy, that is resistance, to the voltage, and then the potentiometer sensors will be converted into a transducer. Well, what is the correlation that we will see? A very simple circuit is shown on your screen. There is a resistance element, sliding contact. This resistance element has two ends, A and B. A has resistance Ra and the node B has a resistance Rb. We are applying a supply voltage Vs across these two terminals, two ends A and B. The voltage at the sliding contact is Vo. Now, let us try to find out the correlation. The voltage at A is I into Ra, but the current which is flowing inside this circuitry can be written in this format. So, I is equal to the supply voltage and total resistance across A and B, that is Ra plus Rb. So, we can consider this is equation 1 and equation 2. So, put equation 2 in 1, then we are getting Va is equal to Vs into Ra divided by Ra plus Rb. So, the voltage at point A is a function of the supply voltage, which we know, which is the constant supply voltage that we are applying, resistance at node A and resistance at node B. Now, as we know, the resistance R is directly proportional to length of the contact and is inversely proportional to the area of the cross section of the wire. So, R is equal to rho into L by A, which is quite well known equation, where rho is nothing but the constant of proportionality and it is called as electrical resistivity. So, resistance is directly proportional to the length and inversely proportional to the area. So, let us use this correlation and modify the equation of Va. So, what we get here, Va is equal to supply voltage into the length of contact from point A and the total length of the resistance element, that is La plus Lb. So, as you can say, from point A, if we are varying the sliding contact length, then we can consider there is a change in potential difference, and that is nothing but the potentiometer. So, what are the various applications of the potentiometer? So, potentiometers are used in throttle valve. So, throttle valves are used to control the flow of the gas or the fluid inside the combustion chamber. So, to monitor the operation or to monitor the displacement of the element of the throttle valve, these are either manually operated or the automatically operated. So, when the manual operation is carrying out or when the automatic operations are carrying out, so we need to monitor whether the specified or whether the desired amount of displacement is there or not. The next is adjustment of voltage. This is very common application. So, we also do have lot of electrical appliances at home. The ceiling fan, to control the speed of the ceiling fan, we are using a knob, we are using a device, and that device is having the potentiometer sensors. We are just rotating the knob and accordingly there is a change in the speed. Then for the acceleration as well, so this is the pedal, and when we apply a pressure or a force on this pedal is getting displaced. So, we need to continuously monitor the displacement of the pedal, because this displacement of the pedal is accelerating the automobile or it is accelerating certain process. So, if it is beyond the limit, then we have to give certain alarm or we have to control the acceleration. So, for that purpose we need to have the controlled movement of this pedal. Earlier it was used with the cables. The next type of application is electronic suspension. So, in this application the lever which is attached to the axle of the automobile, the displacement of that lever will be sensed by using the potentiometer sensor. So, as the lever is moving, that movement can be sensed by the microprocessor. The lever is moving due to the unevenness on the road, as it is getting bumps or you can say the vibrations from the road unevenness through the axle. So, that will be sensed by this lever, and the microprocessor is taking certain decisions or it is giving alarm to the rider, either to control the speed of the automobile or it itself will take the decisions to control it. In addition to this, there are variety of other applications. So, in machine tools potentiometers are required. Machine tools has many elements or mechanisms. There are displacement of these elements and mechanisms. So, we need to monitor them. So, for that purpose potentiometer sensors are required. Elevators, the elevators are moving in upward direction or they are coming downward direction, the movement or displacement of the elevators. The liquid levels in assemblies, to monitor the liquid levels. So, these liquid levels are connected with a physical element or mechanical element. As there is a change in level of the liquid, the mechanical elements are moving. So, that displacement can be monitored and the liquid level can be controlled. Forklift trucks, the forklift trucks are having forklifts which are lifting the commodities. The lift or the displacement of the forks, that to be monitored. For that purpose we need the potentiometer sensor. This already I have talked to you. The throttle valves, control of injection molding machine. The injection molding machine has very critical parts, the two dies that to be closed regularly, and when we are carrying out the closing and opening operations of the dies and the molds in the injection molding operation in a rapid way, we need to continuously monitor the opening and closing of these dies and molds and shutters. So, for that purpose the potentiometer sensors are used. Then for the woodworking machinery to measure or to monitor the displacement, printing applications, printing machineries, spraying applications, robotics, the potentiometer sensors are used. Well, my friends, let us summarize the lecture 1 of week 4. In this lecture, we studied the meaning of the measurement system. It is an important building block of the mechatronics based automated system. We learned the definition of the term sensor and transducer. We understood the difference between a sensor and a transducer. Then we looked at various types of sensors which are used in automation in manufacturing. Basically, we have seen the classification, and then we started studying the potentiometer sensor. We have seen its principle of operation, constructional details, and the important applications in the industry. In the next lecture, that is lecture 2 of week 4, in this lecture we will study the strain gauge based sensors, capacitive elements, linear variable differential transformer, ED current based sensors, strain gauge based sensors, capacitive elements, LVDTs are used to measure the displacement. ED current based sensors and inductive proximity switch are used as proximity sensors. Thank you and see you in lecture 2 of week 4.